Okay, moving right along to number 31. So in number 31, I'm asked to write a sinusoidal equation for each of the following graphs. So in number 31, the first thing I like starting off doing is actually finding the amplitude. So in this case, I see the amplitude would be 5 minus 1, since it's the largest number minus the smallest, and then that's 4 over 2, which is obviously just 2. So I've got my amplitude, that's a good start. Now, I also want to find my vertical shift. There's two ways to find the vertical shift. One is you can look at what the midline was. Obviously, the midline in this case was 3. So the vertical shift is going to be 3. The other way that I could think about it is I could think about it as where I would want my function to start. I think the easiest way, though, is the midline. And I already know enough to write my function. I can write y is equal to 2 sine x plus 3. My amplitude went right there, and my vertical shift went right there. Now, letter B. I noticed that my period is no longer what I was expecting. In letter A, I noticed that the period was 2 pi, so I didn't have to worry about it. But now I notice the period is different. So the first thing I'm going to work on in letter B is figuring out what k is going to be. So my period equals 2 pi over k. So in this case, I can tell that the period is 4, since it took me 4 units to make a full rotation. So 4 equals 2 pi over k. If I multiply on both sides by k, then I have 4k equals 2 pi. And if I divide both sides by 4, then I have k equals pi over 2, since 2 pi over 4 would be the same thing as pi over 2. So I'm going to get rid of that work, just clean this up a little bit. And I know now k equals pi over 2. Whoops. K equals pi over 2. And I need to find my amplitude. My amplitude in this case would be 3 minus negative 3, so that'd be 3 plus 3, which is 6. So my amplitude is 6 divided by 2, which is 3. So I've got my amplitude, I've got my period. I can tell that there is no vertical shift since I started right at 0. So I'm ready to go ahead and write my function. My function in this case would be y equals 3 sine. And remember, I've got to include k, so it'd be pi over 2 x. Last one. This one's a little bit trickier. So I see that between this point and this point, I added by 6 pi. So I'm going to add another 6 and get 13 pi over 6 right here. So now I can tell that my period lasted, I can tell that my period in this case was not 2 pi, rather it was from pi over 6 to 13 pi over 6, which actually is 2 pi. So even though it doesn't look like this has a normal period, it does, because to get from here to here is 12 pi over 6. 12 pi over 6 is really 2 pi. So my period's in okay shape. I've got to find the amplitude. So in this case, the amplitude would be 2 minus negative 6, so that's 2 plus 6 over 2. So that's 8 over 2, which is obviously 4. So I've got my amplitude. The only other thing I need to find is my vertical shift, since I didn't start right where I was expecting to. My vertical shift in this case would be negative 2, since that's where the midline is. And the last thing I need to consider is this is clearly set up to be a cosine function, judging by how it's shaped. And I see it moved pi over 6 units to the right. So when I'm writing this, I need to include a phase shift of pi over 6 units to the right. So my equation then is going to be y equals 4 cosine. And now I need to include x minus pi over 6, since I moved pi over 6 units to the right, and my vertical shift was down 2. Now next, I've got to determine the equation that best describes a sine curve with an amplitude of 3. So I know right off the bat I can write down y equals 3 sine x, because I have the amplitude. And I'm told that the period is 6. So let me use that to help me find k. So 6 equals 2 pi over k. So that gives me 6k equals 2 pi. And I divide by 6 on both sides. So I'll wind up with k equals 2 pi over 6, which is pi over 3. So that means I can write pi over 3 right here. Now I'm also told that it has a phase shift of pi over 2 units to the right. So if I'm going to go to the right, that means I need to subtract by pi over 2. And I'm not told that there's a vertical shift, so I'm all done with my function there. Now in number 33, I'm asked to state the amplitude, period, phase shift, vertical translation, and any reflections. And then we're asked to graph. Let's start out by just finding the amplitude and all that other good stuff. So in this case, the amplitude is obviously very easy to find. It's just 2. So amplitude equals 2. And I can tell that my phase shift is by pi over 6 units to the right, since it's subtracting. Pi over 6 right, not left. And I can also tell that the vertical shift is 5 because I'm adding the 5 at the end. So the vertical shift equals 5. And I can also tell that there is no reflection in this case, so I'm all done with the information they needed me to give. The only thing I still need to do is I still need to sketch out what a graph of this would look like. So, based on my amplitude being 2, that's going to tell me that I can move 2 units away from my midline. So in this case, my midline would be right at 5. So I'll put 5 right there. And that means my lowest point is going to be down here at 3, and my highest point would be up at 7. Now, since we're graphing a sine function, I'd normally expect it to start at 0, but in this case, the lowest thing I can get to is 3. And then I expect that I will wind up with a sine function that increases, and I would hit 5 at pi over 6 units, since I moved pi over 6 units to the right. And I'm going to hit 7 when I get to pi over 3, so again, because I had that phase shift. So I'll be up here at 7, and now I've got a decent sketch of my graph. So that gives me a sketch of letter A, so I'm all done with letter A, and we can start moving on to letter B. So in letter B, I'm told the amplitude is 5. That's nice and easy. Remember that the amplitude is the absolute value, so it can't be negative. Now in this case, it's a little bit tougher to tell what the period is. Remember that your period is 2 pi over k. And in this case, k is 2, so your period here is pi. Remember that k is always the value that's right there. Alright, so we've got our period. Now I can tell that by the plus 1 right here that I'm moving 1 unit left. So that's a phase shift of 1 unit left. And now judging by the negative in front of the 5, this was a reflection over the x-axis. So I've given them all the information that they want, and now I just need to sketch a graph of this. So normally I'd expect cosine at 0 to be 1, but in this case the amplitude was 5, so we're going to start out all the way up at positive 5. Now, it's important to notice that since I had the phase shift and the period shift, that by the time I get here to 1/2, I'm already going to be down at 0. And by the time that I get 1 unit, I'll be down here at negative 5. And that's really all I need to graph before I get a sense of what this function will look like. Now it'll just keep repeating. And I've given my graph now. So let's do letter C. In letter C, I see that I've got no amplitude. My amplitude is just 1. And I can tell that my period in this case is going to be a little bit tougher to find. So the period is 2 pi over k. And k in this case is 4, so it's 2 pi over 4, which is pi over 2. So I've got the period. It's just pi over 2. And now, the next part that's a little bit trickier is the phase shift. So, since this was not factored for us, the x minus pi was not factored, we have to do it ourselves. So the phase shift is going to be equal to negative c divided by k. In this case, negative c was negative pi. Negative pi. So that's positive pi, and in this case k was 4, so the phase shift is going to be pi over 4. And I can tell that my vertical shift was 2 units down, and there's no reflection here. So my vertical shift equals 2 down. And now all I've got to do is just graph, letter C. So I can go through and graph this. And first off, I know that my midline is right here at negative 2. So that tells me that I'm going to be starting right here at 0. I'll be at negative 2. And now based on my period being just pi over 2, I would expect that by the time I get to pi over 2, I've completed a full cycle of this. Now, the lowest that this should get based on the amplitude would be negative 3, negative 1. All right. So I started at negative 2. I'm going to go down to negative 3. And again, by the time that I get to pi over 2, I'm expecting to be back down to negative 2. Oops. Should have brought that down a little bit earlier. Let's fix that, because I can't go above negative 1. There we go. And we've got a sketch of what this would look like, and of course I could continue it.